Hello everyone, myself Nilesh Prasad. Welcome you all in my YouTube channel. Okay, today we are discuss the topic of chemical thermodynamics. The topic is first law of thermodynamics. Okay, what is the chemical thermodynamics? And in chemical thermodynamics, the topic we are uh, see today or learn today is first law of thermodynamics. Okay, अभी अगर मैं आपको यहाँ पे सिंपल सी बात कहूँ कि व्हाट इज द फर्स्ट लॉ ऑफ थर्मोडायनेमिक, you can simply say that the first law of thermodynamics is purely based on the energy concept. Okay, like what is the energy concept? You can see there are many different type of energy conservation you can see all around us. Like you can see there are many energy are conserved in the form of potential energy. Okay, form of kinetic energy. If you see in the molecules or in the atom, their energy is conserved in the form of bond energy also. Okay, uh, mainly we discuss in first law of thermodynamic is conservation of energy. Okay, तो यहाँ पे आई थिंक यू हैव टू नो कि आज हम लोग क्या यहाँ पे डिस्कस करने वाले हैं. तो मेन पॉइंट इज द इन फर्स्ट लॉ ऑफ थर्मोडायनेमिक इज कंजर्वेशन ऑफ एनर्जी. ओके, कंजर्वेशन ऑफ energy. What is the first law of thermodynamics and what is the formula for the first law of thermodynamics? There is two formula. Like one is if you are differentiate the energy in form of small energy. Okay, and second one is like mainly we can consider energy in the form of like potential energy, kinetic energy. Okay, and this all type of energy are conserved in inside the atom or inside the molecule, correct? Then the first law of thermodynamics state that delta U is equal to delta Q plus delta W. Okay, and here what is the delta U? Okay, delta U is nothing but is internal energy. Okay, change in internal energy, correct? Change in internal energy. Okay, and second point is what is the delta Q? Okay, delta Q is the change in heat. Okay, and last is delta W. Okay, what is the delta W? Is change in work. Okay, change in work. So you have seen there is some point like delta U, delta Q और delta W. Okay, यहाँ पे आपको बहुत अच्छे से क्लियर तरीके से आपको ये सारे के सारे जो पॉइंट है वो उनके बारे में आपको यहाँ पे पता चला. ओके, कि व्हाट इज द डेल्टा टी, व्हाट इज द डेल्टा क्यू एंड व्हाट इज द डेल्टा डब्ल्यू. ओके, simple. We also going to write in differential form. Okay, and differential form is nothing but the small amount of change in C in first law of thermodynamics. Okay, then the second point will be we also we also write in differential form. Okay, differential form like du is equal to dq plus dw. Okay, this is the second formula for first law of thermodynamics. Okay, in this formula you can see here du is the change in internal energy, delta u is change in the internal energy, but du is small change in internal energy. Okay, small change in internal energy. Okay, and dq is small change in heat. Okay, and del dw is small change in work. Okay, we can clearly see here there is two different formula according to your concept. Like if you are calculating like only in internal energy change, or mainly we can calculate for internal energy, we can calculate the small change in internal energy, because we can't easily find the internal energy change in any system like molecules, atoms, or any substance. Okay, but if we parted this molecule in a small pieces, okay, we can easily count their small change in internal energy. Okay, and what is the first law of thermodynamics? There are some definition will be there for first law of thermodynamics. Okay, the definition is: first law of thermodynamics state that energy cannot be created, okay, or cannot be destroyed. It can be converted from one form to another form. Okay, you can see here the first law of thermodynamics state that if you have a some kind of energy, like we can consider like potential energy, kinetic energy, the energy will be remain constant. Okay, but the form of energy will be changed. Like if in one system the energy is there in the form of kinetic energy, if they transfer to the another system, energy will be the same. If in a first system energy will be the 10 kilocalorie per joule, in another system, second system, energy will be the same 10 kilocalorie per joule. Okay, but it can converted in one form to another. Like in first one, if the energy is conserved in the form of potential energy, it can be converted into either uh, kinetic energy like bond energy or something other. Okay, but it can't be destroyed or it can't be generated for our purpose. For we can't generate or generate the energy, we can't create or we can't destroy the energy. Okay, we already see the what is the first law of thermodynamics. Okay, we already see their definition, we already see their formulas for the conservation of energy and first law of thermodynamics. Okay, अभी यहाँ पे we have to discuss one each point for the first law of thermodynamics. Like first is what is the internal energy, second is the what is the heat concept, okay, then what is the work done inside the first law of thermodynamics. Okay, the first point is internal energy. Okay, you can write here the small point, internal energy. Okay, internal energy. Okay, and it is denoted by u. Okay, it is denoted by u. If you see, there are many types of internal energy. You can see the formula for the total energy is the total energy is equal to the energy will be the form of kinetic energy, correct? It will be the form of potential energy, or it will be the form of internal energy. Okay, but kinetic energy are always created by the motion. Okay, and potential energy are created due to the some gravitational electrostatic forces. Okay, electro gravitational electrostatic field, okay, and internal energy is due to internal energy are present inside the system, okay, it it already present inside the system. इफ यू सी, अगर आप कभी भी देखोगे तो इंटरनल एनर्जी आपको, जो कोई भी सिस्टम, इफ यू चूज एनी सिस्टम, ओके, इन आवर सराउंडिंग, इन आवर यूनिवर्स, देयर आर सम काइंड ऑफ इंटरनल एनर्जी विल बी देयर इनसाइड द सिस्टम, ओके, क्योंकि इफ यू सी, if you break any chain, any reaction, okay, you have to put some energy to break their energy, okay. तो इससे आप क्या एक कंक्लूजन वी हैव टू क्रिएट कि आपके पास कोई भी अगर सब्सटेंस है, कोई भी अगर आपके पास मॉलिक्यूल्स है, they are bindly together due to the some kind of energy, okay. The energy is known as the internal energy, okay. The energy between the two bonds, like carbon carbon will be there, oxygen oxygen will be there, okay. There, this is the one molecule, like O2 is the single molecule, but they are bonded with the two oxygen, okay. And this type of energy is known as the internal energy. It will be either in the form of bond energy, in the form of bond, in the form of electrostatic force of attraction, or it will be form of many different type, you can see, okay. Next is, if you consider a molecule, okay, like I consider one molecule, okay. If you consider a molecule, okay, I am going to consider a molecule. You can see here, this is a molecule, okay. In molecule, inside the molecules, there are some kind of internal energy will be present, okay. You can write here, inside the molecule, inside the molecule, some kind of internal energy will be present, okay. If you see any kind of molecules like the unimolecular, okay, polymolecular or diamolecular molecules, in every molecule there are some kind of internal energy will be present inside the molecule, okay. And the form of energy like kinetic energy, okay, potential energy, and bond energy, okay. Also there are also some other different type of energy you can also see in the form of internal energy, okay. And now we have to discuss what is the internal energy, okay, and how we calculate using molecule, then inside the molecule the some kind of internal energy will be present, but how we can decide the internal energy of the molecule, there are some concept will be there, okay. If we discuss the internal energy of molecule, okay, internal energy, okay. What is the internal energy? Internal energy is nothing but the sum of kinetic energy, okay. It also in the form of kinetic energy plus kinetic energy, okay. All the all the energy present inside the molecule is equal, okay, like kinetic energy, potential energy, bond energy, okay. If you see the internal energy, you can see there are three different type of kinetic energy you will see, okay. First kinetic energy will be generated from the translational molecule, okay, translational molecule, okay. And second type of kinetic energy will be produced by vibrational molecule, okay. And third type of kinetic energy will be produced by the molecule, okay. You can also see some kind of other internal energy like potential energy. Okay, potential energy is due to the force of attraction. Okay, bond energy due to the energy between the bonds. Okay, bond energy. If you see, the first potential is generated due to the electron and nucleus. Okay, in electron and nucleus there is the electrostatic force of attraction will be there in the form of potential energy. Okay, second, the potential energy is formed in the form of force of attraction. Okay, force of attraction between the molecules of if you consider the two molecules in the same field, there are some attraction will be there in two molecules. Due to their attraction, the energy will be generated in the form of potential energy. Okay, the last is the bond energy. What is the bond energy? Energy between the bond. Okay, energy between bond. Okay, you can see here, you can clearly see there are a number of different type of internal energy. You can see like kinetic energy in the form of transitional molecule. Okay, kinetic energy due to the vibrational molecule, kinetic energy due to the molecules, potential energy due to the electron and nucleus. Okay, potential energy due to the force of attraction, and bond energy is due to the energy between bond. Okay, it is impossible to determine the internal energy of a system. Okay, why we can't determine the internal energy of a system? Okay, if you consider a system, okay, like suppose I have a system. Okay, this is a system. अगर आप कभी भी देखोगे तो सिस्टम फर्स्ट किस में आप कंसिडर करते हो? एट रेस्ट पॉइंट. ओके, अगर आप कभी भी रेस्ट पॉइंट पे अगर आप कोई सिस्टम को कंसीडर करते हो तो यहाँ पे आपको किसी भी तरीके का इंटरनल एनर्जी देखने के लिए नहीं मिलता है. ओके, why we can't see internal energy in the any kind of system? Because there is no any kind of repulsion will be there. In scene, repulsion will be there, attraction, neither attraction nor any type of motion will be seen here at rest position. Okay, in system there is not determine the internal energy. Okay, now the second point is importance of calculate of delta U. Okay, delta U is nothing but the change in internal energy. Okay, why we need to calculate the delta U? Okay, because अगर आप कभी भी देखोगे ना, जैसे इफ आई एम कंसिडर एज अ मॉलिक्यूल. ओके, सपोज अगर मैं आपसे कहूं कि मेरे अंदर कितना अमाउंट ऑफ इंटरनल एनर्जी विल बी प्रेजेंट. ओके, यू कांट कैलकुलेट using any kind of mathematical, any kind of experimental on my body or on mathematicals. Okay, तो इस कंडीशन में हम क्या करते हैं, कभी भी अगर यू हैव टू कैलकुलेट इंटरनल एनर्जी, यू ऑलवेज थिंक अबाउट देयर चेंजेस इन एनर्जी. ओके, आप कभी भी एक पर्टिकुलर अमाउंट ऑफ एनर्जी को आप कैलकुलेट नहीं कर सकते. ओके, क्योंकि because energy is continuously fluctuating. Some time energy will be low, sometime energy will be high. Like in human being, you can see if we eat proper food, proper meditation, uh, we do the proper gym, the energy will be high. But in some day you can see if you do the all the things for your body, like you do the regular gyms, you eat a healthy food, but after then you can't get a same energy. Okay, तो इसमें हम ये प्रॉपर बिल्कुल नहीं कह सकते कि आप अगर ये सारी चीजें करोगे तो भी आपका जो एनर्जी लेवल है वो बोथ द डे विल बी द सेम. ओके, ऐसा बिल्कुल नहीं होने वाला है. तो एनर्जी विल बी डिफरेंट ओके। तो इस कंडीशन में हम क्या करते हैं, इस कंडीशन में वी नीड टू कैलकुलेट द चेंज इन इंटरनल एनर्जी। ओके, इसके लिए हम कभी भी अगर आप देखोगे तो हम डायरेक्ट यू को कैलकुलेट नहीं करते, वी वी जनरली कैलकुलेट द डेल्टा यू। डेल्टा यू इज नथिंग बट द चेंज इन इंटरनल एनर्जी। ओके, तो इसका एक बहुत इंपॉर्टेंट यही यूज होता है कि इंपॉर्टेंट ऑफ इंपॉर्टेंट ऑफ कैलकुलेट delta U. Okay, what is the delta U? Delta U is nothing but the change in internal energy. Okay, change in internal energy. Okay, and the formula for the internal energy is delta U is equal to delta Q plus delta W. Okay, now it is the extensive property depend on the matter amount. Okay, अगर आप सपोज कोई कंसिडर करते हो एक मास या फिर मैटर, लाइक वी कैन give example, like we can consider a beaker. Okay, the beaker size will be the different. First beaker is 1 liter. Okay, second beaker is 3 liter, and last beaker is 5 liter. Okay, if you fill with the water, okay, or any kind of material, okay, and you can apply the some force from upward, okay, you can easily see the difference in their internal energy. Okay, why you see the difference in the internal energy? Okay, if you change the volume of your volume or mass of the object, you can see there are difference in their internal energy. If you consider a large mass, if you consider the large volume of masses, you can apply the more force than the smaller one. Okay, अगर आप सिंपली अगर आप ज्यादा मास वहां पे है, ज्यादा अगर फोर्स लगाते हो, तो उसके अंदर आपको मोर अमाउंट ऑफ इंटरनल एनर्जी यू विल सी। ओके, करेक्ट। if we consider one internal energy, okay, like delta U. Okay, delta U is nothing but the change in internal energy. In for the state function, change in internal energy depend on change in internal energy is depend on initial and final point. Okay, and one more point is it does not depend on path function. Okay, the second point is it does not depend on path function. Okay, what is the meaning of path function? Let's consider one example, like we have a two energy like difference like A and B. Okay, if we move from A to B, okay, on uh, A to B, okay, there are some kind of energy will be used for path 1. Okay, this is a path 1, and the energy are used in the path 1 is delta U1, correct. Then another path is if we go from B to A, okay, this is the path 2, correct. In path 2, the energy is used in delta U2. Okay, if we compare the both the energy on path, you can see there if delta U1 is equal to delta U2. Okay, correct. And the path function and the energy internal energy for the path function is 0. Okay, that's why it does not depend on path. Okay, the next point for the internal energy is in a cyclic in a cyclic path. Cyclic path we already see here on the depend on path function. Same will be for the cyclic path. Okay, the internal energy for the cyclic path is delta U is equal to 0. Okay, and how to calculate the value of delta U value? The next point is how to calculate delta U value. Okay, there are some formula for calculating the delta U. Delta U is equal to delta Q plus delta W. Okay, uh, if you calculate the value of delta U, you can use the ideal gas equation for value of delta U. Like you already know, the ideal gas equation for internal energy is delta U is equal to NCV delta T. Okay, for a change, okay, change in internal energy, and second one is du is equal to NCV dt. Okay, this is for the small change in internal energy. Okay, small change in internal energy. Okay, both the formula are only applicable in ideal gas equation. Okay, ideal gas. Like what is the in this equation? If you see, the delta U is change in internal energy. Okay, change in internal energy. Okay, what is the N is the number of moles. Okay, number of moles. What is the CV? CV is the molar HSE at constant volume. Okay, and what is the DT? Delta T or DT? DT is the change in temperature. Okay, if you consider DT, so DT is the small change in temperature. Okay, change in temperature. Okay, if you find the value of delta U, you can first find the value of CB. Okay, what is the value of CB? CB is the formula of CB is F upon 2 multiplied by R. Okay, what is the F? F is the degree of freedom. Okay, degree of freedom. Okay, if the F value is 3, it is for monoatomic gases. Monoatomic gases. Okay, if the value of F is 5, it's for diatomic. Okay, if the value of F is 6, it is for polyatomic. Okay, according to your gases, you can select the value of F. Okay, R is the universal gas constant, and the value of R is 8.314 joule per mole. Okay, and R is also denoted with the 2 calorie per mole in form of calorie. Okay, if your question asks in the form of calorie, you can put 2 kilocalorie per mole in the place of R. Okay, and the value of internal energy is directly proportional to the value of temperature. Okay, internal energy is directly proportional to the temperature changes. Okay, and it's only applicable for ideal gas, not applicable for the another gases. Okay, so you can clearly see here there are there we can find the value of delta T with the help of CV. Okay, we can also find the value of delta Q, delta W. Okay, we first change the places of delta W, delta Q. You can easily find the value of any like delta Q or delta W. Okay, here the some question are asked on the basis of first law of thermodynamics. The first question is why internal energy of ideal gas is said to be only kinetic energy. Okay, you can see for ideal gas equation, okay, the internal energy for ideal gas is always zero. Okay, why it is zero? Because in ideal gas equation, okay, there is no force of attraction, no force of attraction are seen among the molecules. Okay, and it is denoted as a potential energy. Okay, then the formula for internal energy is, for ideal gas equation, is kinetic energy plus potential energy. Okay, but the potential energy it will be zero. Then ideal gas equation for internal energy is kinetic energy plus kinetic energy plus kinetic energy. Okay, and the value of kinetic energy will be only said to be only kinetic energy, not the potential energy or bond energy in the form of ideal gas. Okay, second one is what is the heat. Okay, you can see in your first law of thermodynamics there are another concept of is delta U is delta Q plus delta W. What is the delta Q? Delta Q is nothing but the heat in the form of energy exchange. Okay, let's see the delta Q. The another point in first law of thermodynamics is, second point in the first law of thermodynamics is heat. Okay, delta Q is denote with the delta Q. Delta Q is nothing but the change in heat. Okay, if you donated only Q, the Q is represented as a heat. If you denoted as a delta Q, delta Q is represented the change in heat. Okay, and heat is the form of energy exchange. Heat is the form of energy exchange. Okay, and there are two types of heat we generally saw in the first law of thermodynamics. If the heat is given, if the heat is given to the system, okay, it is always be the positive. Okay, if the heat is given by the system, इट ऑलवेज बी द नेगेटिव. ओके, अभी यहाँ पे ये बात समझना बहुत ज्यादा इंपॉर्टेंट है कि हीट इज गिवन टू द सिस्टम इज ऑलवेज पॉजिटिव. ओके, एंड हीट इज गिवन बाय द सिस्टम ऑलवेज नेगेटिव. ओके, व्हाई? अगर मैं यहाँ पे सपोज आई हैव टू कंसिडर वन एग्जांपल लाइक दिस इज द सम काइंड ऑफ बॉक्स. ओके, जहाँ पे किसी भी तरीके का कोई भी ये नहीं है. ओके, यहाँ पे एक नॉर्मल एनर्जी पहले से ही क्या है, प्रेजेंट है. ओके, इफ वी प्रोवाइड द एनर्जी फ्रॉम आउटसाइड. ओके, हमने क्या किया है, यहाँ पे एनर्जी इसको प्रोवाइड किया फ्रॉम द आउटसाइड. तो इसमें क्या होगा, आप देखोगे कि इसकी जो एनर्जी होगी, ऑफ कोर्स द एनर्जी विल बी, energy is increasing, correct? If the same box we consider, okay, and if we liberate the energy from inside the box, okay, you can see here the energy is decreasing. करेक्ट. अगर आप किसी भी बॉक्स के अंदर से अगर आप किसी भी बॉक्स से एनर्जी को निकालते हो तो वहां पे क्या होता है कि आपका नेगेटिव चार्ज, वहां पे एनर्जी कम होती है. If energy is decreasing, it will be represent as the negative energy. Okay. If energy is given to the system, अगर आप कोई एनर्जी अगर आप किसी सिस्टम को दे रहे हो तो उसमें उस कंडीशन में the system is getting the positive energy. Okay. The formula for the heat is Q is equal to mc delta T. Okay. What is the m? M is the mass. Okay. M, not n. Okay. What is the C? C is the specific heat capacity. Specific heat capacity. Okay. And delta T is the change in temperature. Okay. Change in temperature. Okay. Now for the ideal gas equation, using the ideal gas equation, we can find the value of Q or value of heat. Okay. For ideal gas equation, you can write down here for ideal gas. Okay. For ideal gas, the value of Q is Nc delta T. Okay. Here N is the number of moles, C is the molar specific uh, heat capacity. Okay. And delta T is the change in temperature. Okay. N is the number of moles. Okay. C is the molar specific, because we are consider here the number of moles, molar specific heat. Okay. Capacity. And delta T is the change in temperature. Change in temperature. Okay. And if we apply at the constant pressure, what is the value of delta Q? Okay. And what is the value of Q? Okay. For the constant pressure, the first point is like Cp, apply on constant pressure. Okay. The value of Cp is Cv plus R. Okay. Second point is Cv. Okay. Apply on constant volume. Okay. The value of Cv is Cv is equal to F upon 2 multiplied by R. Okay. F is the degree of freedom. Okay. Degree of the freedom is depend on the atoms. Like if you consider the monoatomic gases, then the degree of freedom will be 3. If you consider the diatomic, the degree of freedom will be 5. If you consider the polyatomic gases, the degree of freedom is 6. Okay. Now the next point is work. How we calculated the work. Third point is work. Okay. Work is denoted as capital W, or if you consider the delta W, so delta W is nothing but the change in the work. Okay. If work is done either on the system or by the system. Okay. The two type of work are generally seen on the system. First one is work done on the system. Okay. And second one is work done by the system. Okay. The work done on the system is always positive and work done by the system is negative. Okay. इसमें आप एक सिंपल सा एग्जांपल क्या कर सकते हो, आप खुद का एग्जांपल ले सकते हो. ओके. अगर आप सपोज यू हैव टू डू एनी वर्क, आपको क्या करना होता है, यू हैव टू अप्लाई सम काइंड ऑफ एनर्जी, ओके। अगर आपने कहीं पे कहीं काम करते हुए कुछ वर्क लगाया, ओके, तो उस कंडीशन में आपकी जो एनर्जी होती है, यू हैव टू लॉस्ट, ओके। अगर आप कहीं पे बैठे हो, अगर आप कोई चीज बाहर से ले रहे हो, ओके, लाइक समथिंग यू हैव टू कंज्यूम सम फूड और सम काइंड ऑफ एनर्जी स्टफ्स फ्रॉम आउटसाइड, ओके, तो इससे क्या होती है कि आपकी जो एनर्जी होती है वो इंक्रीज होती है, ओके। तो वर्क डन ऑन द सिस्टम इज पॉजिटिव, वर्क डन बाय द सिस्टम इज नेगेटिव, ओके। एंड हाउ वी कैलकुलेटेड द वर्क, द फॉर्मूला ऑफ द वर्क इज, the formula for the work is nothing but the force into displacement, okay. And also the formula for the work is mgh in form of gravitation, okay, 1 upon 2 kx square, okay, either charge into delta v, charge into volume, okay. It's also considered to be the work, okay. And for the ideal gas equation or for the gases, we can calculate the work, like if we consider a ideal gas, okay. For ideal gas, work is W is equal to minus P external, okay, multiply by delta V, okay. This is the formula for work for ideal gas equation, okay. W is nothing but the area under pressure and volume curve, okay. And delta V is the change in volume, like the final volume minus initial volume, okay. This is the formula for delta V, okay. Now we can see the some kind of question to related to the first law of thermodynamics. The first question is, you can write down. The first question is, okay, if we consider 500 calorie of heat is given to a system and system perform 350 calorie work, calculate change in internal energy of system, okay. The change in internal energy of the system, the formula for the change in internal energy of the system is delta U is equal to delta Q plus delta W, okay. We already know the delta Q is plus 500 calorie because work is done work is done to the system, okay. And delta W is minus 300 calorie, okay, because it performed by the system, okay, work, that's why it will be the negative 300, okay. Delta U is equal to delta Q is the 500, okay, minus plus minus 300 calorie, okay. The value of delta U is plus 150 calorie, okay. The change in internal energy of the system will be the plus 150 calorie, okay. This is the basic formula you can apply for this type of question, like what is the internal energy, what is the change in internal energy of the system. The formula for the change in internal energy of the system is delta U is equal to delta Q plus delta W, okay. You can put the value of delta Q or delta W, you can find the value of delta U, okay. If we if the if in this question we can ask the value of delta Q, you can also find the value of delta Q or delta W, okay. uh, the next question for related to the first law of thermodynamics is, second question is 0.5 moles of O2 is heated from 25 degrees Celsius to 125 degrees Celsius at constant pressure. Calculate Q, delta U and W. Okay, you can see here the value of Cp is given here 7 calorie per mole Kelvin. Okay, now how can I find the value of Q, W, delta U or W? Okay, we have the value, we have the formula for Cp or we have the formula for Q. Okay, Q is Nc delta T. Okay, and what is N? N stand for number of moles, Cp delta T. Okay, N is the number of moles, like 0.5 multiplied by Cp is nothing but the formula of Cp is F upon 2 multiplied by R. Correct. F is for diatomic is 5 for O2. 2 multiplied by R. R in the form of calorie is 2. 2 and 2 will be the cancel. Cp is the 5. Okay. And here you can calculate Cp. No, it's Cv. Okay. It's Cv. Cv will be the 5. Okay. Cp multiplied by delta T. Delta T is how many delta T? How much? Delta T is the difference between the temperature. 125 degree minus 25 degree is 100 degree Celsius. Okay. For delta P is the formula of delta P is Cv plus R. Okay. What is the Cv? Cv is 5 plus 2 is equal to 7. Okay. You can put here the value of Cp is 0.5 multiplied by 7 multiplied by 100. Okay, what is the answer for the Cp? Q is plus 350 calorie. Okay, now you can also find the value of delta U. Okay, the value of delta U is formula for the delta U for number of moles is NCV delta T. Okay, N is equal to 0.5, Cv is 5 and delta T is 100. Okay, the value of delta U is 250 calorie. Okay, now the last is W. Okay, how would you find the value of W? Okay, the for first law of thermodynamics we can know delta U is delta Q plus delta W. Okay, what is the delta Q? Delta Q is 350 plus delta W. Delta U is 250. Okay, 250 minus 350 is equal to delta W. Okay, what is the final value of delta W is minus 100 is equal to delta W. Okay, and what is the conclusion for this answer? Work done by the system. Work done by the system. Okay, now we are completing this topic. Our topic is first law of thermodynamics. If you find any difficulty or if you find any mistake in this video, you can comment down. Okay, and you can personally contact me on Instagram or Telegram. The links are given to the description box. You can click and join my Telegram channel. You can get the uh, get the PDF or notes of the each and every chemistry topics, and also you can contact me in personally and share your doubts. Okay. Thank you so much for watching my video, and please do not forget to subscribe my channel, and please share with your friends. Okay. Thank you so much for watching my video. Thank you so much. See you in next